How's it going, y'all? Well, here we are again, and this time we're looking at evaluating different types of roots. Now, I know you're going to probably think to yourself, Mr. Rodriguez, didn't we already do this? And the answer is yes, we have. The difference is before we're just dealing with square roots. Now we're going to be dealing with cube roots, higher power or higher roots like sixth roots, and some cubics. And what I want to show you essentially how to do it. The process we use is not any different, but what's going to change is how we're going to use the calculator in this case. So I just want to kind of just give you some quick examples on what functions we're going to use in the calculator in order to get cube roots, six roots. And then down here, I'm actually going to show you what the cube root, we're going to be doing now with the expansion of the cubic type functions. And we're going to go from that point on. Okay. So we'll start with the cube root first. Okay. So let's just say we want to evaluate a value. Let's just go with, I don't know, let's make something up. Let's go g to the fourth. What that essentially means, again, we're going to basically take x, g of 4. We're going to take 4. We're going to evaluate 4 as x here. We're going to take the cube root of 4 minus 2. Well, obviously, we know 4 minus 2 is 2. So what we're looking for is the cube root of 2. Now, some of you won't be able to do this in your head, and I understand that. I know, not that big a deal. And, if I ask you something like, what's the square root of 4? You could tell me it's 2. Well, if I ask you what's the cube root of 4, you're probably going to be like, I don't know. That's okay. That's kind of why we have this. And to do a cube root, it's pretty straightforward. Math is going to be your favorite function here. There are probably different ways of doing it, but math is probably the main one. We go into the math, and what you see is right number 4 here, you have a cube root value, and we use that function to determine what we're going to look for. So basically, if we're looking for the cube root of 2, we hit cube root of 2 this time, and we get the value is going to be 1.259. Okay, so we know that the g of 4 is equal to 1.259. Okay, and what this essentially means is that if we're looking for the cube root of something, okay, I'll take a step back real quick. If we're doing a square root of something, let's say we're doing a square root of 4, what we know is essentially that square root of 4 is equal to 2 because, 2 times 2 is equal to 4. Well, the cube root is the same structure, except that instead of it only being 2 times 2, the cube root is basically saying what value times itself is equal to, in this case, 2. Well, 1.259 approximately, if we multiplied that by itself 3 times, the value would be somewhere close to 2. Now, it's not going to be exact, and I'll show you what I mean by that. If I do 1.259 times 1.259 times 1.259, we get 1.9956. And the reason for that is because we're using irrational values, so we're rounding irrational values, which means it's not going to be exact anytime we do it. If we really wanted to do this, we would do something like we would try and get this as close as possible, as many decimals as possible, in order to get closer to 2, but we're not going to get exact numbers. So let's just kind of make you aware of that. These rounded numbers are just rounded exactly that. So it's not going to exactly be 2. So it's an approximation more than anything else, okay? So like if I looked at here, the sixth root of 3x plus 2, well, again, let's just say I want to evaluate h of, let's just pick 2 again because I like 2 for whatever reason. And we're going to figure out the sixth root of 3 times 2 plus 2. Well, again, we go, 3 times 2 is 6 plus 2 is 8. So what we're looking for is the sixth root of 8. And again, what that means is, we can take a number 6 times. I lost track. And the value we get would be 8. Well, again, to figure that out, if you don't know this, which, most people probably wouldn't be able to do that, we come back to our calculator and figure out, okay, what's the sixth root? Well, if we go back to our math, right below the cube root is this little x root value. And what that is used for is being able to do powers beyond cubed or squared, things of that nature. So in this case, I want to change this to 6 and figure out the 6th root of 8. And when I do that, I get that it's 1.414. Okay, so that's what we're doing now with these. We're looking for cube roots, 4th roots, 6th roots, 5th roots, whatever it might be. So that's what we're going to be evaluating. That's what we're going to be working with. Okay, not too bad. And so this is going to be calculator driven because we're looking for the decimal value or the value, the approximate value that if we did this to the power of 6, then we would get really close to 8, but not exactly 8 because, again, it's an irrational value, and we're rounding the rational value. Okay. Now, on something like this, where we're going to start doing a little bit more expansion, I'm going to zoom this just a little bit here. Again, if I had the J of 4, I would plug in 4 plus 2 cubed times 2. That's pretty straightforward. I'm not going to mess a whole lot with that right now. But what if we have something like, if we're going to evaluate like J of x plus 1? Well, again, all that means is that we're going to evaluate x plus 1 plus 2 cubed. Well, simplify the interior first before we do anything else. And then a common mistake, I've seen this, is basically go, oh, look, it's x cubed and 27. No, don't do that again, please. We're past that. What this cube means, it's very similar to what I just showed you. It basically tells you that we have this factor of x plus 3 times. That means we have x plus 3, x plus 3, x plus 3. So it's an expansion, okay? So now we're actually going to start simplifying these and start putting them together to come up with different types of polynomials, which is what we're coming up to pretty soon. So we're going to go ahead and take this. We're going to expand it and work our magic with some FOIL and some box. And I'm going to be honest with you. I'm going to start with FOIL first. I'm going to use Punnett squares on these. It's a little bit, keeps things a little bit more organized. And again, if you know how to do this without using a Punnett square the first time through, that's fantastic. It can save some times. Okay. Because the next Punnett square I'm going to use looks something like this. And the answer I use from these is actually what I'm going to drop here. Because I can do a third Punnett square now. That becomes x cubed, 6x squared, 9x, 3x squared, 18x, and just kidding, 27. Okay. So that as I take this and rewrite it, I saw that 2 there, by the way. You know, I have x cubed. I have 3 and 6, which becomes 9x squared. 18 and 9, which becomes 27. And, of course, 27. And then all of that times 2, distribute my 2 through. So I end up with 2x cubed plus 18x squared plus 54x plus 54. And such that j of x plus 1 is equivalent to 2x cubed plus 18x squared plus 54x plus 54. So that's what we're going to start seeing more of now. We're going to start seeing a little bit more expansion, getting ready to go into polynomials. This is kind of the first time we start seeing it. But notice the Punnett square, the way I set it up here, it's pretty straightforward when we're going to be doing these. Don't try and make anything else up unless you just really want to do it a FOIL method where it's just all horizontal distribution. That's up to you, but truthfully, this is going to kind of be your best bet and not the simplest, but the most efficient way of doing this. Anyway, we'll see you later then.